All right, Newton's third law of motion. For every action, there's an equal and opposite reaction. That is the law. So here's some examples. Fish uses its fins to push water backwards, but a push on the water will only serve to accelerate the water. Since forces result in mutual interaction, which means equal and opposite, the water must also be pushing the fish forwards, which allows the fish to go through the water. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water backwards is opposite the direction of the force on the fish forwards. So for every action, there is an equal in size and opposite in direction reaction force. Action-reaction force pairs make it possible for fish to swim. A bird flies by using its wings. The wings of a bird push air downwards. Since forces result from mutual interactions, the air must also be pushing the bird upwards. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air downwards is opposite the direction of the force on the bird upwards. So for every action, there's an equal in size and opposite in direction reaction. Action-reaction force pairs make it possible for birds to fly. A car is equipped with wheels that spin. As the wheels spin, they grip the road and push the road backwards. Since forces result in mutual interactions, the road must also be pushing the wheels forward. The size of the force on the road equals the size of the force on the wheels. The direction of the force on the road backwards is opposite the direction of the force on the wheels forwards. For every action, there is an equal and opposite reaction. Action-reaction force pairs make it possible for cars to move. So here we got a baseball and a bat, right? So the bat hits the ball. The bat is applying a force to the ball, and then the ball is applying a force to the bat. They are equal in force, and they go in opposite directions. The ball goes back this way from its force, and the bat goes back that way. How about baseball catching a ball? The ball hits the glove, right? And the glove pushes backwards. The ball applies a force to the glove to go this way, but the glove applies the equal force of the ball back at it. And that's what slows the ball down. And then lastly, bowling. If you bowl the ball and it hits the pin is moving leftwards. The pin is applying a force to the ball, making it go rightwards. Equal and opposite. Balloon. You got the air particles pushing out on a balloon. The balloon is pushing back on the air particles. Equal force, opposite direction.